So now let's move on to testing multiple restrictions. Testing multiple restrictions. So far we've talked about how to test a single restriction on a single parameter, as well as a single linear combination of parameters with one restriction. So now we have learned how to test one parameter, one restriction, and two multiple, one restriction with a linear combination of parameters. So one restriction, but a linear combination. That says linear right there. A linear combo of, I'm just going to say parameters, param for parameters. So now let's focus on multiple restrictions, like multiple hypothesis, we'll say, hypothesis about multiple parameters. Okay, so that's what we're going to learn now. So for example, we'd have like a null hypothesis that was, beta 1 equals 0 and beta 2 equals 0. So two equal signs, so two restrictions and two parameters. That's what I mean by that. All right, so let's talk about exclusion restrictions. So we want to test whether a group of variables has no effect on the dependent variable, or y. For instance, let's say we have a regression with 5 x's, or 5 independent variables. And let's say we want to test whether x3, x4, and x5 have no effect on y. All right, so I'm going to quickly erase this and I'll rewrite this regression model at the top, and then we'll continue talking about this. All right, so let's rewrite that regression out, or I'll rewrite it. I guess you probably don't need to. Just helpful to have it on the same board for me. So we have 5 x's, and hopefully you remember the error term last time, but there's definitely an error term on there. And we want to test whether x3, x4, x5 affect y. So you want to test whether these last 3 independent variables have any effect on y. So in essence, what our null hypothesis is beta 3, so the effect of x3 on y equals 0, and beta 4 equals 0, so the effect of x4 equals 0, and beta 5 equals 0. So they're all equal 0. Another way to put that would, same thing, would be beta 3 equals beta 4 equals beta 5 equals 0. Same thing. So this is going to be a test of joint hypothesis. So this This is just two ways of putting a joint hypothesis. We want to test whether these things hold at the same time. And so when we think about what our alternative hypothesis should be now, remember that it's this doesn't hold. Well, this doesn't hold if beta 3 doesn't equal 0 and or beta 4 doesn't equal 0 and or beta 5 doesn't equal 0. If any one of these things doesn't equal 0, then this null hypothesis should be rejected. So this is going to, we got to remember this and or between these restrictions in our alternative hypothesis. So the key here is that we cannot test these hypotheses one by one. One by one, we'll put it like that. So we can't run like a t-test on each of these three restrictions individually and make a conclusion. We can't do that. The results of that test will not be reliable. So a simple t-test puts no restrictions on the value of other parameters. And the conclusions from running three separate t-tests or calculating three separate t-ratios and making conclusions, it's going to be pretty complicated to make a conclusion about that based on three kind of t-tests. So we're going to take a different approach to this. And the approach is going to be that we're going to see whether including these variables in our regression decreases the sum of squared residuals enough to warrant putting them in the regression. So that's kind of the intuition behind what we're going to end up doing. So I'm going to just erase this bottom part, leave this regression up here. So this is the null hypothesis, this is the alternative, and we just can't test them one by one. So let's think of a different way to test them.